Okay, everybody, we're going to go ahead and get started. So if you're on the outskirts, come on into the inskirts. We're going to be talking about using Amazon Nova Act to simplify login workflows. Please put your hands together. Give a warm welcome to your speakers, Anand Srinivas and Floris van der Gritten.
Hey, what's up, folks? First off, we're super excited. Thank you very much for coming in. And we're super excited to be talking about being a Nova Act launch partner and using Amazon Nova Act to simplify login workflows. And my name is Anand Srinivas. I'm the VP of Product and AI here at 1Password. And I'm here with Floris van der Gritten, who's a senior developer in the developer at AI at 1Password as well. Perfect. So the thing I want to get started with is 1Password. We're pretty well known for our security model. There's actually a 70-page white paper out there if anyone wants some bedtime reading about exactly how that works. And we recently updated that security model for agentic AI and what we think is important. And so I just want to go through a couple of these that are key here. The first is this idea that secrets stay secret. We have a very strict zero-knowledge model where any system hosted by 1Password cannot decrypt your credentials. And that's the model that we intend to keep with agentic AI as well. The second and third here, authorization should be deterministic, not probabilistic, and that raw credentials should never enter into a model's context. Those have to do with things like MCP. So for instance, sending raw credentials down the MCP channel is probably not best practice, right, is how we look at that. And so we look for deterministic workflows to transfer credentials in that way. And then the rest of the principles are all around transparency, auditability, and other aspects of it. So overall at 1Password, the way we look at AI in general is there's a component of this which is using AI within our products. And so we might call that AI for security. And actually, Floris will be covering that later on today. And that's exactly how we use the Nova Act models to make the 1Password product better, right? And so he'll cover that. The other side of this is security for AI, which is using 1Password's products to help secure agentic AI as they are deployed. And so that's the part I'm going to talk about a little bit before I hand off to Floris. But before I do, what I want to sort of talk about a little bit is a sort of taxonomy that will make this discussion a little bit more clear and useful, hopefully. So the way we look at AI, or agentic AI in particular, is on the vertical axis of this. We classify it into two broad categories. The first is agentic AIs that interact with other applications and services by clicking around in a web browser, or more generally, computer use, right? They're mimicking a person in terms of like that interaction. The other type of agentic AI uses programmatic means. So think MCP, APIs, other kinds of standard approaches that way. And then on the horizontal axis at the top is where these agentic AIs are deployed. Are they deployed on your device, like on your laptop, or are they in the cloud, right? And so if you look at what this looks like in practice, just some examples. So when a browser use style agentic AI is running on your laptop, examples of this are things like Perplexity or OpenAI's Atlas browser, right? And the use cases here, you're just automating something on behalf of yourself, right? Whereas in the cloud, now we're talking about Nova Act plus something like Agent Core browser tool, where the use cases are, hey, I don't want to have to sit in front of my laptop and run this. I can run this asynchronously in the cloud. It can be automation for myself. It can be an internal application for employees, or it can be a production application that's deployed in the cloud, that's deployed on behalf of customers, right? So any of those use cases. The other side of this is programmatic. And so again, on your laptop, what this looks like is something like Cursor, right? Or Lovable, or Claude Desktop, right? And the use cases here are a lot about vibe coding, but it's just about automating and making yourself more efficient as well. And then the cloud version of this are deployed applications, or applications that are built through agent builders, or AI that's embedded in other applications like Notion, for example, Notion AI. And the use cases here, again, are very similar to the use cases for the cloud applications for browser use agentic AI as well. And so what we're going to focus on for this talk, because it's relevant to Nova Act in particular and our launch partnership with AWS, is the first side of this, or the top half of this, which is around browser use agentic AI. But hopefully we'll be back at another day to talk about the programmatic AI stuff as well and how 1Password can help secure that side of it as well. So getting into that, the first one I want to talk about is remotely deployed browser use style agentic AI. So think about this as there's a headless browser running in the cloud, right? And there's an LLM that's driving that headless browser. And basically you can prompt that LLM and just let it run asynchronously. And obviously, for it to be of any value, it has to log into things, right? It has to log into different websites, access different services, and so on and so on. So how do we solve that problem, right, of getting those credentials securely filled on behalf of the agentic AI without actually giving those credentials to the agentic AI into the context window? And also without a person having to pause the thing and manually type it in and remember their password. Hopefully we've gotten over those kind of problems. And so we recently made an announcement. We're going to be making many more announcements with partners on this, where our solution is we actually have a 1Password browser extension running inside the headless browser in the cloud. And what we're able to do is when that agentic or that LLM wants to access some website, it asks that browser extension, hey, I would like to fill in this website. And previously, you would have actually connected the service and 1Password. Right? So in this example, we made an announcement with a company called BrowserBase. And so you would, beforehand, connect BrowserBase with 1Password, and sort of that sets it up. And what happens is in the flow, the LLM asks the browser extension, can I fill this website? The browser extension asks you, the person, right? It gives you an auth prompt and says, hey, BrowserBase headless browser is trying to access this particular website and wants your credentials for it. Do you authorize it? And so you would approve that flow. And basically, the credentials are sent end-to-end encrypted, right, where they're only decrypted inside the browser extension that is actually in that headless browser. And so that's the solution that we've come up with here that solves this problem of, again, filling the credentials on behalf of the agent in a secure, encrypted way without exposing the credentials to the agent. And some of the things going forward that we're working on are things like asynchronous workflows, right? So how do you set policy, right, on the fact that, okay, well, maybe I don't want to approve every single credential. There's some low-risk ones that can just go through, no problem, right? But maybe some higher-risk ones, I do want like an explicit human-in-the-loop auth prompt. And so some of the things like that we're working on. But that's an example of browser use agentic AI in the cloud, how we're securing that. The next part of this is, what about browser use agentic AI that is running on your laptop? How do we secure that? And so here, recently we've announced partnerships with Perplexity, as well as OpenAI's Atlas browser as well. And we're launch partners with them, and the only security launch partners with them. And basically the idea is the 1Password browser extension can work on these browsers. And so it solves at least the problem of, again, you're not manually typing passwords into these things, right? You're able to fill it from your vault, right? And then going forward, what we'll be looking to do is add more automations to this particular workflow as well. And so, hopefully that kind of gives you an idea that, at least on the browser use side, that's the breadth of how we're looking at sort of how to secure agentic AI. And as I said earlier, hopefully we'll be back in the future to talk about the programmatic AI stuff as well. So with that, what I'm going to do is I'm going to hand off to my colleague Flores, and he's going to get into how we're actually using the Nova Act models within the 1Password product to solve important production use cases. Flores?
Cool. Hi, I'm Flores from the engineering team at 1Password, and I'm going to be showing you how we're using agentic AI at 1Password to improve our own product in a way that just wouldn't be possible in a pre-AI era. And the star of the show here is really Amazon's Nova Act, which launched here at reInvent. And it's their browser use agentic AI solution. So let's talk about autofill. 1Password comes with a browser extension, as you may know. And this adds a small icon in login form fields. And if you click that icon, you can choose a credential, the credential that you want to use to log into the website, and then 1Password does the tedious work of logging in and filling out the form. So that's how it works today. But we're working on the next generation now of autofill, and we're calling it universal sign-on. And with universal sign-on, we really want to take the experience of logging in from, hey, 1Password, fill in this logging form for me, to a more holistic, like, hey, 1Password, just log me in, do whatever it takes to log me in. And so, regardless of the login method. So whether that's a username password, a TOTP for MFA, enterprise SSO, a passkey, or a sign in with GitHub or Google, which you probably forgot which one you used for which website again. And so here's how that looks. So I click on the website and it automatically goes to the login page, signs me in, enters the password, enters the TOTP, and I'm logged in with just a single click, hands off the keyboard. Now, so how does this work? Unfortunately, there's not a standard protocol for logging into websites. It's free for all HTML with lots of ambiguity. And for classic autofill, we have more or less solved the ambiguity with a one-size-fits-all or a one-size-fits-most algorithm that's based on heuristics. And it's been working great, and it's being used millions of times per day by many users. But now for universal sign-on, we're running into the limits of the heuristics that we can articulate in our code. Because now the browser extension, it wouldn't just need to know how to fill in the form, it also needs to know how to navigate to and through the form, which is much more complex to do. So ideally, we would have website-specific logic here. Because every website is different. And to make this a success and to realize the universal sign-on vision, this is what we're going to need. The problem is, though, as you can probably guess, this doesn't scale if you have to do this by hand. Because, yeah, there are millions of websites out there that offer a login, that offer logins. And also, even if we were to do this, it's going to be brittle, because at the scale it would operate on, we would see breaking changes every single day. So that's not really an option. So now with Nova Act, we can finally solve this. We can scale this up. So what we've done, we've built an AI agent using Nova Act that goes out on the web, browses these websites for us, and it gathers the intelligence that we need around how different websites offer logins. And the intelligence is then validated by a second agent, which also uses Nova Act, to validate whether the information that we get about the login experience is correct. And then it gets fed into what we call the site intelligence engine. And that exposes it to our browser extension. And the browser extension then uses the intelligence to enhance the existing algorithm for a smooth login experience. And this runs, what's nice about this is that it can run out of band. So it can run in our infrastructure and gather the intelligence and pass that to the browser extension, so that the browser extension, the login experience will just stay blazingly fast and also deterministic. And what's also nice is that we can run the validation agent periodically in the background to see if the intelligence is still correct or not, and if not, invalidate it. So let's have a look at how the Nova Act agent does this. So we're going to have it browse to the reInvent website, and the instructions that we give is find how this website offers login. And this is a pretty simple example because there's a big login button on the top right. So it should be able to find it here. Let's see if, yes, clicked it. And it's able to find the login form, and it knows this is the login form, so I'm going to return. If we look at a slightly more complex example, here is the website for Duolingo. And this is a bit more difficult because it doesn't have a traditional login button. It just has a button that says, I already have an account. And to make it a bit more complicated, it's not a standard button with an href that links to the login button, but it's a JavaScript click handler. And this would be much more complicated to build it in a heuristic-based algorithm. But for humans, it's easy. Humans just click, I already have an account. And because Nova Act uses the same human kind of reasoning, it's still easily able to get to the login page, which is really great. And along the way, Nova Act also posts logs every step in the evaluation loop that it takes. And as you can see, it really thinks like a human here. It reasons like a human. So it says that it finds a button that says, I already have an account, which likely links to the login form. Then it knows, okay, I need to click that, and then it actually is able to perform the click. And lastly, it will evaluate it again, and then it reasons about, hey, this is the login form, so I'm done with my task. So to recap, website-specific intelligence can meaningfully improve the 1Password products in a way that just wouldn't be possible in a pre-AI era. And we really just only scratch the surface of what agentic AI can do for our product. But if you want to try it out and get a glimpse of this new universal login experience, you can install the beta of the 1Password extension, which already has this new UX and the first data intelligence powered by Amazon Nova Act. So, thank you for listening.
We can take some questions. Yeah.